Hey everybody, in this lesson we're going to look at how to graph the sine function and the cosine function. First we're going to learn how to draw the basic graphs of sine and cosine, and then we're going to learn how to use amplitude and period to do transformations on those graphs, and then finally we'll look at some graphs and work backwards to figure out what the equation was that they came from. So let's get started. First of all, you should know that trig functions are periodic functions, meaning that their values repeat in a pattern over and over, a lot like this EKG pattern that we've all seen probably on television, if not in real life. So a periodic function is one that repeats, and the period is the length along the x-axis from the beginning of one cycle to the beginning of the next cycle. Now every period should have the same length in a periodic function, and so you can subtract any beginning point of one cycle from the beginning point of the cycle before it, and that will give you the period. So first we're going to look at the sine function. Now the trig functions are called periodic because they repeat as theta increases. So if you can imagine the terminal side of an angle here, as the angle increases, the sine function is changing, because remember the sine function is the vertical coordinate. So if we start the terminal side of theta here, then as theta increases, the y coordinate is increasing until we get to 1. And when we get to 1, the vertical coordinate begins decreasing until it gets to 0. And then it continues decreasing down to -1, and then finally it increases back to 0. And if we were to let our angle grow past 360 degrees, we'd just go around the circle again, and the sequence of y values would repeat itself. So the sine function is periodic. And remember, as we do this, we're fixing to generate a couple of periods of the sine function. As we do this, remember that the sine function is the vertical coordinate from the unit circle. Okay, let's start here at 0 radians. And, well, actually, first we're going to label our x and y axes. So what we're going to do is label the horizontal axis every pi over 2 radians. And, of course, you can see from the unit circle that the y coordinate is never going to get bigger than 1 or less than -1. So let's just go ahead and label our x-axis. See, every pi over 2. So pi over 2 plus another pi over 2 puts us at pi, then 3 pi over 2, then 2 pi, and so on. Okay, now we'll imagine an angle traveling around the unit circle, and we're thinking about the y coordinate because we want to think about the sine of this angle. So we're thinking of the y coordinate, and as we start at 0 radians, the y coordinate is 0. So we'll put a dot, C, at 0 sine value. Then as the y coordinate grows so that the angle is pi over 2, then the y coordinate is 1. So we graph a 1. At pi over 2 radians, we have a sine value of 1. And then we let the angle grow until the sine value, or until the angle rather, is pi, and then the sine value will be 0. And then let the angle grow until it is 3 pi over 2 radians, and the sine value will be -1. And then let the angle go to 2 pi, and the sine value will go back to 0. And if we went around the circle again, we would get that same pattern again. And when you connect the dots, it looks like this. It forms a smooth curve. It does not make a up and down like a triangle shape. It doesn't go straight from here to here. It's not a straight line. It should be a gently sloping curve. Not a semicircle and not a straight line, but a gently sloping curve up and then down. Think about ocean waves. Alright, now let's think about the domain of this function. So the domain is all the angles that can be plugged into the sine function, or in other words, all the x values that the graph can have. And we know that every angle has a sine value, Sine is never undefined, so the domain is going to be negative infinity to positive infinity. Then range is the y values, the set of all the y values. So the lowest y value we can possibly have for sine is -1, and then the highest is +1. And then period is how many radians does it take to get from the beginning of one cycle to the beginning of the next cycle. So here we start at 0, we end at 2 pi, so it takes 2 pi radians to get that done. And the x-intercepts, look where they are happening at 0, 1 pi, 2 pi, 3 pi, 4 pi, and so on. And so the x-intercepts are happening at every n pi, where n is an integer. And whenever you use the n variable, you need to also specify what n can be. So we usually want to set things up so that n can be an integer. Now notice that the basic shape of our sine function is middle, high, middle, low, middle. And here's another cycle of the sine function, and again you see the same pattern. Middle, high, middle, low, middle. Middle, high, middle, low, middle. And that forms a sine function. Okay, now it's very important for you to be able to draw your own sine function and to do it quickly without having to put too much thought into it. So we're going to practice just a little bit. I want you to practice this a couple of times on your own. In your notes you have two sets of coordinate system, so you should be able to draw it at least twice, but you should maybe get some other paper and draw it a few more times on your own just to make sure that you've got it and that it sticks. So when you draw the sine function, first you want to label your x-axis. You'll need a starting tick mark at the origin and then 4 more tick marks, and then for every period more that you want to draw, 4 tick marks after that. Okay, now label your y-axis. I've got here -1 and +1, and I went ahead and labeled the end of each period. We know the period is 2 pi, so from 0 to here is 2 pi, and from here to here is 2 pi more, and 2 pi plus 2 pi is 4 pi. Okay, after you get your axes labeled, then go ahead and label your, or put your dots down. So remember the pattern is middle, high, middle, low, middle. Middle, high, middle, low, middle, and then do it again. And then just connect the dots in a smooth curve. Okay, so it's really important for you to know that the end of each label, the end of each function, is 2 pi more than the one before. So this one's 2 pi, this one's 4 pi. And this is the curve, this is the function, y equals sine of x. Okay, now let's do the same thing for the cosine function. So remember that cosine theta on the unit circle is the horizontal coordinate. And here I've got us another unit circle and another coordinate system. So we'll do the same thing we did for the sine function, only instead of thinking about the vertical coordinate as we go around the circle, we'll think about the horizontal coordinate. So here we start at 0 radians. And at 0 radians, the cosine value will be 1. Well, before we plot it, let's go ahead and label our axes. I've labeled the vertical axis from -1 to +1, and the horizontal axis from 0 to 4 pi, because I want to go around twice and get 2 whole cycles. So, like I said, let's go ahead and plot. At 0 radians, the cosine value is 1, so I'll put that here. And then let's let theta increase to pi/2. The cosine value then will be 0. And then let's let theta increase to pi, and the cosine value then will be -1. So here we have -1. And let theta increase to 3 pi/2, and the cosine value will be 0. So back to 0. And then let's let theta increase from 3 pi/2 to 2 pi, and the cosine value will go to 1. And as we go around the circle a second time, we will see the cosine values go through the same pattern again. And we're going to connect the dots with that smooth curve just like we did last time. Okay, now notice how similar this is to the sine function. It's almost exactly like it, only instead of our pattern starting at middle, this time our pattern starts at high. So that's really the only difference between the way the sine graph looks and the way the cosine graph looks. If we think about the domain of the cosine function, remember domain is all the angles that can be put into a function, or all the numbers that can be put into a function. And so here we know that every number can be plugged into the cosine function. Any number can have a cosine, and cosine is never undefined. So the domain is going to be negative infinity to positive infinity. Now the range is all the set of all the y values, or all the outputs that can come from the function. And so here we see that the cosine value goes back and forth between -1 and +1. So the range is -1 to +1. And the period is how many radians it takes to get from the beginning of one cycle to the beginning of the next cycle. And so we see here that the range is, the period is 2 pi. And that makes sense because you have to go all the way around the circle to complete one period. Alright, now the x-intercepts. This can be a little tricky to think about the first time. Notice that the x-intercepts are occurring at pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. So you might be tempted at first to say that the x-intercepts are all the half pi's, but don't be too fast about that, because notice that even 1 pi could be considered 2 halves, and 2 pi could be considered 4 halves. So you really don't want to say that every n pi over 2 is an x-intercept, because if n is an even number, then we've got a problem. But it's okay for n to be an odd number. Now, it's a little funny because we don't normally write n pi where n is an odd number. We tend to like to keep n as an integer. So instead of writing n pi where n is an odd number, let's do something to n to force it to be odd. What we normally do is we write this. So if we're going to let n be any integer, then 2 times that integer will make an even number, and then any even number plus 1 will make an odd number. So this is kind of math code or math symbolism for an odd number. So we want to say the odd pi over 2's, so I'll write this expression, odd pi over 2's, and I'll specify now that n can be any integer. And the basic shape of the cosine, I'm sure you noticed on the last slide, but we'll go ahead and write it down here for sure, is we've got high, middle, low, middle, high. So look at it here. High, middle, low, middle, high. Now the funny thing is that if you were to start back here, you'd pick up the sine pattern. See, if you start back here at negative pi over 2, you get middle, high, middle, low, middle. That's the sine function if we start back here, but it's the cosine function if we start here at the axis. So one way you can say that is the cosine function is the same graph as the sine function, but shifted pi over 2 radians to the left. The cosine is just the graph of sine that's been shifted pi over 2 to the left. Okay, now let's practice drawing cosine. And so what we're going to do is, just like we did with sine, we're going to label our axes. And this time I've only labeled the end of each period. But what you're going to do is you're going to put a tick mark at the origin and then 4 more evenly spaced marks. And every 4 marks makes a period. So 1, 2, 3, 4, that's the end of my first period, so that's 2 pi. Then 1, 2, 3, 4, that's the end of the second period, so that's 4 pi. And now let's go ahead and put the dots for our pattern. It goes high, middle, low, middle, high, and then repeat. And now connect. And there is a graph of 2 periods of the cosine function. Now we're going to start doing some transformations, and we'll start with amplitude. The amplitude is the height of the graph from the middle to the top. But you could also say the height or the distance from the middle to the bottom. They should be the same, but we always say middle to top. And so in the function a sine of x, the amplitude is going to be the absolute value of a. Now notice that a itself can be positive or negative, but amplitude is always considered positive even if a is negative. So we're really talking about amplitude as the absolute value of a. Okay, now what we're going to do here in example 1 is we're going to graph 2 sine x and then compare that to the graph of y equals sine x. And what I've done is I've gone ahead and drawn in our basic y equals sine of x graph. And so what I did was middle, high, middle, low, middle, and I did it twice to have 2 periods. Okay, now if you think about 2 sine of x, that really should just be the basic sine of x times 2. So every y value from the original graph that I have here in purple, but times 2. So wherever the sine function is 0, 2 times 0 will still be 0. And wherever the sine function is 1, 2 times 1 will be 2. And wherever it's negative 1, 2 times negative 1 will be negative 2. So when you think about the effect that this a number has on the graph, it just stretches it vertically. So it makes it more exaggerated, but notice it does not change its x-intercepts at all, because 0 times any coefficient would still be 0. Okay, now that we know that this is what the a number does, we really won't need the original graph anymore. We won't have to draw it in, that is, to see what effect the a is going to have. So from now on, we'll just know that a affects amplitude, and it'll stretch the graph out like that. We can think of the a number as a vertical stretch when the amplitude is greater than 1, and a vertical shrink when the amplitude is less than 1. Okay, now in this example, we're just going to practice graphing y equals 3 cosine x. So the first thing we need to do is label our axes. Always do the axes first. In this case, we can see that amplitude needs to be 3, so let's label our y-axis up to 3 and down to negative 3. And then let's do our horizontal axis. You know, this is still the basic cosine graph, just with an amplitude of 3. So we're still going to have a period of 2 pi. So I'm going to go my starting mark on the axis, on the origin, and then 1, 2, 3, 4 evenly spaced marks, and that fourth mark is the end of our first period, so that's 2 pi, and then 4 more evenly spaced marks, and that last one is 2 pi away from the first 2 pi that we had, so 2 pi plus another 2 pi makes 4 pi. Okay, now we will put our dots in. Remember, the basic pattern for cosine is high, middle, low, middle, high. So here we go, high, middle, low, middle, high. And we'll go ahead and do it again. So we have 2 periods, and now we will connect the dots. And there's our cosine function for y equals 3 cosine x. Now if a is negative, the graph will undergo a reflection about the x-axis, or what you might have called a flip in middle school. So it's going to turn upside down. Remember, amplitude is always considered positive, but a itself can be negative. Okay, here we have y equals negative 2 sine of x. So notice that a is negative 2, but that means that amplitude is positive 2, and there's going to be a reflection. Okay, let's go ahead and get our axes set up. The vertical axis needs to be labeled from -2 to +2 because of the amplitude. And the horizontal axis, because our period is still 2 pi, horizontal axis will be labeled with a starting mark on the origin, and then 1, 2, 3, 4 evenly spaced marks, and this will be the end of the first period. So the period is 2 pi, and then 1, 2, 3, 4 more marks, and then that'll be another period. So take the 2 pi we had before and add 2 pi, and now we're at 4 pi. And so we've got our axes set up. Now let's think about what this reflection means. The basic pattern of sine is middle, high, middle, low, middle. If we turn it upside down, it's going to go middle, low, middle, high, middle. And so that's what it means to have a reflection. It means it turns it upside down. So when we put our dots in place, we have to remember that this one is upside down. It's been reflected across the x-axis. So middle, low, middle, high, middle, and then repeat. And we'll connect the dots. Okay, there is our graph of -2 sine x. Okay, now we're about to graph functions that look like sine of bx or cosine of bx. And the b number that we see here is going to affect the period. Remember, period is the distance along the horizontal axis from the beginning of a cycle to the beginning of the next cycle. In the graph of sine bx, b controls the period. So we've already been graphing sine of x and cosine of x, and we know that the coefficient of x in both of these cases has been 1. So we've already drawn graphs where b was equal to 1. And we know that as long as b is equal to 1, the period will be 2 pi. We've already seen that in the graphs that we've drawn so far. But a lot of times b is not equal to 1. And if b is not equal to 1, you have to calculate the period. Now the formula I'm about to give you does work when b is equal to 1. It's just that you shouldn't need it because you already know that if b is 1, period is 2 pi. But if b is not 1, we'll need to calculate it, the period. So period equals 2 pi over b. You should memorize this formula, because at any time you might have to calculate the period and you need to know the formula. So 2 pi over b, and remember b controls the period and no other variable controls period, just b. Okay, here's how we're going to go about graphing sine bx and cosine bx. So this is just for one period, and you can repeat this as many times as you need for more periods. But the first thing you do is divide the x-axis into 4 equal parts. A starting tick mark, which so far for us has always gone at the origin, and then 4 more tick marks. And these are the interval from 0 to 2 pi over b, which is your first period. And then you're going to label the last tick mark, which is the end of the period. And if you need to label the other tick marks, you can do that. You can take the period and divide it by 2 to get the middle tick mark, or divide it by 4 to get the quarter tick mark. And then after you've got the tick marks labeled, one cycle of the graph should fit on those 5 marks. Remember your basic shapes. For sine is middle, high, middle, low, middle. For cosine is high, middle, low, middle, high. And then you'll have your graph and you can connect the dots. Okay, let's practice drawing sine of 2x, and let's compare the graph of sine 2x to the graph of sine x. So what I've done here is I've drawn a coordinate system with the first 5 tick marks where it goes out to 2 pi, and so that holds exactly 1 period of the sine function, middle, high, middle, low, middle. And now I'm going to do a little calculation. we can see here that in sine of 2x, we can see that amplitude is 1, and we can see that b equals 2. So we're going to use the b number to calculate period. Period is 2 pi over b, which in this case is 2 pi over 2, and that means period is pi. Now, if this is 2 pi, then pi should be halfway between 0 and 2 pi, so that'll go right here. And the end of the first cycle is what we always do to get the label at the end of the cycle is we go 0 plus a period. And so the end of the first cycle will be right here at pi. And the second cycle will take where we left off plus another period. So if we stopped at pi before, then pi plus another period will give us 2 pi. So there's my label. All right. Now I need 5 tick marks between here and here. Remember, the first one goes at the origin. So my starting tick mark plus 4 more evenly spaced marks. And so my sine 2x is going to fit on these 5 marks. Middle, high, middle, low, middle. You see that? This is the sine of 2x. Now compare it to the sine of x. You can see that increasing the b number shrank the horizontal space that it takes up because it made the period smaller. And I'm going to go ahead and draw another period of sine 2x. You can see that we're able to fit 2 whole cycles in the same space that we were only able to fit 1 cycle before. So 2 whole cycles fit where we used to only get 1, and b was 2. So the b is controlling the period, but what it's actually telling you is how many cycles can fit between 0 and 2 pi. If b equals 1, then 1 period will fit between 0 and 2 pi. If b equals 2, then 2 periods fit between 0 and 2 pi. We can think of the graph of sine bx as a horizontal stretching of the graph when the absolute value of b is less than 1, and a horizontal shrinking of the graph when the absolute value of b is greater than 1. Remember the graph we just saw of sine bx, sine 2x. Okay, here's the sine of x, and here's the sine of 2x. And remember that because in the period formula, b is on the bottom, as b grows, the period shrinks, and that means that the graph horizontally appears to shrink. Now let's practice a little bit. Y equals cosine 2/3 x, and we're going to graph 2 periods. So first let's analyze what's here. We've got our a equal to 1, and that means amplitude will be equal to 1. We've got our b equal to 2/3, and that means that period will be 2 pi over b, which is 2 pi over 2/3. And whenever you want to divide by a fraction, what you do is you multiply by the reciprocal. And so we're going to end up with a period of 3 pi. Now before we even put our tick marks on the coordinate system, let's go ahead and figure up the end of each cycle. We're calculating our labels now that go at the end of each cycle. So if we're going to start at 0, the first cycle starts at 0 and it goes for 3 pi radians. So 0 plus 3 pi radians will make at the end of our first cycle 3 pi. And the second cycle will start at 3 pi and it will go another 3 pi. And so the end of the second cycle will be at 6 pi. Alright, now let's put our amplitude marks on the y-axis, and on the x-axis we're going to put our first mark at the origin, and then we're going to go 4 evenly spaced marks, and that will be 3 pi, and then 4 more evenly spaced marks, and that will be 6 pi. Alright, now let's think about our pattern here. This is cosine, so the pattern should be high, middle, low, high, starting right here. High, middle, low, high, and then again high, middle, low, high. Connect the dots. There you go. There is your graph of cosine 2/3 x. Now let's look at example 4. We're going to graph y equals -2 sine of 3x over 2 periods. And we'll start by analyzing a. So a is -2, and that means amplitude is 2. Remember, amplitude is always positive. Okay, now the negative on our a means that we have a reflection over the x-axis. Remember, it's like a flip. So it's going to be upside down. B is 3, and that means period is going to be 2 pi over b, or 2 pi over 3. Okay, now we're ready to calculate the end of the first cycle. If we start at 0 and we go out 2 pi over 3, then we'll be at 2 pi over 3. If we start the second cycle at 2 pi over 3 and we go another 2 pi over 3, then we'll be at 4 pi over 3. Okay, so here we lay out our marks on the y-axis, and then we lay out our first mark at the origin and then 4 more evenly spaced marks. And that first one is 2 pi over 3, and then again, and that's 4 pi over 3. Okay, now this is the sine function, so middle, high, middle, low, middle, but it's upside down, so middle, low, middle, high, middle. Like that. And then we will connect the dots. And there is the graph of -2 sine 3x. Now, when b is an integer multiple of pi, the x-intercepts of the graph are going to be rational numbers. It's really not any harder. In fact, it's a little easier than what we've been doing, but because the pi symbol appears in the problem, it throws some people off. So let's just look at one together. We're going to look at -3 cosine of pi x. So first of all, a is -3, and that means amplitude is 3. And now the negative means that we have a reflection over the x-axis. Now b is pi, and then period is 2 pi over b, which is 2 pi over pi, so period is just 2 in this case. Alright, now the end of the first cycle, we start at 0, and we go a period of 2, and that means the end of the first cycle is at 2. And for the second cycle, we start at 2, and we go another period, and that means that the end of the second cycle is at 4. And now let's label our axes. The y-axis, because the amplitude is 3, we label from -3 to +3. The x-axis, because the period is 2, I put my starting mark at the origin, and I go 4 evenly spaced marks, and that one is a 2, and then I go 4 more evenly spaced marks, and that one is a 4. And then this is a cosine, it's upside down. Now cosine is high, middle, low, middle, high, but it's upside down, so it's going to be low, middle, high, middle, low. Okay, and connect the dots. And there is the graph of -3 cosine pi x. Now it will happen sometimes that you'll be given a graph and asked to come up with the function that it came from. So what you really need to do in those cases is come up with the a and the b. If you can find the a and the b, and you can identify whether your pattern is a sine or a cosine pattern, then you've got the function right there. Okay, so this one is telling us to determine the equation of a form either a cosine bx or a sine bx, where b is positive. And so by telling us that b is positive, what they're saying is don't worry about what might happen if b were negative, because that causes a reflection about the y-axis, and we don't want to worry about that. But they're just saying come up with the simplest a and b that you can. Okay, first of all, I notice that the pattern is low, middle, high, middle, low. So I know that that's going to be cosine, and I also know that it's been reflected across the x-axis. Alright, now amplitude is going to be 2. You can see it here. And so if I know amplitude's 2 and a is supposed to be negative, now I know that a is -2. I can also see from the graph that period is 4 pi. the period goes from 0 to 4 pi. And so in my little formula, 2 pi over b, period, is 4 pi. Okay, now to solve this for b, what I'll need to do is multiply both sides by b and divide both sides by 4 pi, and this will simplify to 1/2. So now I can see that b is 1/2. And so in the form a cosine bx, the a is -2 and the b is 1/2. So you can write it this way where it looks like 1/2 x, or you can just write it as -2 cosine of x over 2. Now let me point something out to you here. From 0 to 2 pi, we get exactly half of a pattern. And b was 1/2. Okay, you remember seeing on the previous slide where b was 2 and we fit 2 patterns between 0 and 2 pi? Well, now b is 1/2 and we're fitting 1/2 pattern between 0 and 2 pi. So whenever we're doing this and we can see where 2 pi is on the graph, it's easier just to get b by looking at the graph instead of going through this whole equation solving process. You can often look at the graph and figure out what b is supposed to be. So let's try that on the next example. Okay, in this example we're asked to find the function that this graph came from in the form either a cosine bx or a sine bx with a positive b. So the first thing I want to do is identify the pattern. I can see that it's high, middle, low, and we don't get to see the rest of the pattern, but we can assume that it's high, middle, low, middle, high. And so the pattern is going to be the cosine pattern. And we can also tell from that that amplitude is, or a is positive, amplitude is 3, and the a needs to be positive. Okay, notice that here we've got 1/2 of a cycle, just the high, middle, low, and when we get out to 2 pi, that's where it matters. We're trying to count how many cycles we can see between 0 and 2 pi. Now, they might draw it out to anywhere on the x-axis, but you only care what happens between 0 and 2 pi for the purposes of finding b. So we see that between 0 and 2 pi, we've got 1/2 cycle. That means that b is 1/2. Okay, we already said amplitude is 3. Alright, so now we've got a cosine bx, so 3 cosine bx, or 1/2 x. Alright. These next two are similar to the last two we've done. We're just going to practice for a little bit. Same instructions. So in this one, let's identify our pattern as middle, high, middle, low, middle. And of course we recognize that as a sine function with no reflection. So a is positive. And let's go ahead and get the amplitude. Amplitude, you can see here, is 3, from 0 to 3. Okay, now let's count how many cycles we can see between 0 and 2 pi. So middle, high, middle, low, middle, that's one pattern. And then there's a second, and a third, and a fourth. So between 0 and 2 pi, it looks like we're getting 4 complete patterns, so b is 4. And so now to put it in our formula that we've got, the a is 3, and the b is 4. So we've got 3 sine of 4x. And let's look at this last one. This pattern goes low, middle, high, middle, low. Of course, we recognize that as a cosine pattern that's been turned upside down. And that means for us that a is going to be negative. And you can see that the amplitude is 3. And so a is -3. Alright, now let's count patterns. From 0 to 2 pi, how many patterns do we see? Low, middle, high, middle, low, that's one pattern. Then 2, 3, 4. And so b is 4 again. And so our function will end up being y equals -3 cosine 4x. I hope this was helpful to you, and we'll be looking at some more transformations in the next lesson.